All right, today we're going to complete Unit 4, Lesson 2, and we're continuing with what we've been talking about with exponents. We're adding a new rule today, okay? So before we jump into today's new rule, I want you to write at the top of your paper that exponents are snobby and that they are above everybody else. They physically are above everybody else because they're exponents on top of the numbers and letters, and they only talk to other exponents. Okay? They will only talk to other exponents. So whenever we are discussing this, or if you come to me with a question and you're confused about something, if I find a mistake on your paper, I might just point at it and say, remember, exponents are snobby. Okay? And that is supposed to help you remember what this rule is. So let's go ahead and jump right in with what is the rule. Okay? So to raise a monomial to a power, we will use the power rule. And here's how that works. The power rule will take any exponent in here and it will multiply exponents by exponents, okay? It will not change anything else. It will only change the exponents. So that is an A times B. All right, so let's look at our examples here, 1, 2, and 3. Now with all three of these examples, my coefficients are 1, just like on our last lesson. Coefficients are equal to 1 in this case. So what that means is there's a 1 in front of, whoops, let me just write this initial problem down. So that in number 1, I have a 1x squared, okay? So what I'm going to do here is I'm going to keep the bases the same. So my base here is an x. And if you want to, you could also think about that 1 as being a base, okay? And what this power rule is going to do is multiply this little 1 exponent above my number 1. It's going to raise that to the 5th power. So that becomes a 5. And then the 2 times 5 above the x will become a 10. So that was to the 5th power, okay? So what I like to do when I show my work is just draw a line from the 5 to the 1 exponent and from the 5 to the 2 exponent. But my markers are a little too fat to be working on this board like that. So I end up with 1 to the 5th power times x to the 10th power. And then what is 1 times 1 times 1 times 1 times 1? 5 times. And the answer is it's still 1. So when we have a coefficient of just 1, we don't necessarily need to do the work with the exponents with it, because 1 times itself, no matter how many times, it's always going to be equal to 1. And then my base stayed the same. And then my exponent, 2 times 5, became 10. And that's my final answer for example 1. Let's try example 2. So I have an m and an n. So my bases will stay the same, m times n. And what I will do is my snobby little exponents are going to be talking up here. 7 times 4 is 28. And 4 times 4 is 16. And I'm finished. That's all I need to do with that. Let's look at example 3 and see what makes this one different. Okay, just like you saw me do with the 1 in example number 1, I need to be certain that whenever I have a variable like this, that I know that that is also to the 1st power, because I need my exponents to stay snobby like they're supposed to be and only talk to other exponents. So let's bring down my two bases, C and D, C and D. Okay, now I'm going to do my exponents. 1 times 3 is 3. 2 times 3 is 6. And that's my final answer. All right. I am going to scroll all the way to the bottom of my page, and I want you to add this note right here. And honestly, if you want to pause this video and add these steps down below as well, that'll save us from having to pause the video again in just a couple of minutes. Okay, but I do want you to be super careful with negatives. Remember, if it's inside a parenthesis, then if it's a negative number, we have to copy that negative sign as well. But if it's not in parentheses, the negative does not get copied. Only the number does. So parentheses versus not parentheses makes a big difference with our negative numbers. So go ahead and pause this and just copy all these notes down, and then come on back and we're going to finish up the examples up on the top of the page. All right, so let's dive right in with number 4. What we're going to do first is raise the exponents to the given power, okay? So what are my exponents in number 4? I see the x has a 7, but what does the 5 have? The 5 has a 1, okay? So now we're ready to do our snobby exponents, but let's copy down our bases, 5 and x. So I have 2 times 1 is 2, and 2 times 7 is 14. And then I do have a note right to the left here that says we have to reduce our coefficients. So remember, 5 to the second power is the same as 5 times 5, which equals 25. So I'm just going to write this final simplified answer, 25x to the 14th power. All right. Why don't you try number 5? So pause the video and give that a try. So in number 5, okay, I needed to remember all of my 1s for my exponents. Bring down my bases, 2x, y. Multiply my snobby exponents, so 2 times 1, 5 times 1, 5 times 2, and then 5 times 1 again. And then my last step is going to be to reduce. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is 32. And then I have my x and my y to the 10th and to the 5th. Great job. And I'm going to erase my little scratch work here. Let's look at number 6. Okay, so this is what the note at the bottom of your paper is for, because we want to be very careful with our negative. This negative is inside a parenthesis. So when I bring this down, I'm going to put -2 in a parenthesis, okay? That's my base. And my P is a base, and my Q is a base. Let's make sure that we know what all the exponents are, because now I'm ready to share. So 2 times 1 is 2. 2 times 4 is 8. 2 times 6 is 12. Okay? And now I am ready to reduce my number. -2 times -2 is a +4. And then I keep the P to the 8th and the Q to the 12th. And I can erase my scratch work. All right, what I want for you to do now is to pause the video, and I really do want you to give number 7 and 8 a try. Just don't forget about these 1s, okay? And they both have negative numbers, so I really am wanting you to get some practice with that. And then as soon as you're done with 7 and 8, come check your work, and we're going to do number 9 together. All right, welcome back. I've done number 7 and 8, and I do have some scratch work down here. -4 to the 4th power. I typed that in my calculator, and I got 256. Okay, and so it's negative times negative is positive, negative and negative is positive, positive times positive is a positive 256. Okay, number, oh, and this didn't write very well, but I have, so 256, c to the 12th power, and d to the 16th power. Okay, in number 8, I did some scratch work down here. -3 times -3 is a positive 9. Positive 9 times -3 is where I got to that -27. Okay, great job. Alrighty, now we're ready to do one with a fraction. Okay, so I need to be sure that I know the exponents for both of the numbers in the fraction. Okay, and then I'm just going to share it like always. So 1/2 is a base, A is a base, B is a base, C is a base. So 3 times the one on top is 3. 3 times the one on bottom is 3. 3 times 3 is 9 above the A. 3 times 4 is 12 above the B. 3 times 5 is 15 above the C. Now the only thing here that I'm really left to reduce is the number. So I have 1 cubed over 2 cubed, which really looks like this. 1 times 1 times 1, 2 times 2 times 2. It should be times. So 1 times 1 times 1 is 1, 2 times 2 is 4, and then 4 times 2 again is 8. So 1/8 is what I get for my fraction. And then I keep A to the 9, B to the 12, C to the 15. And that's it. So these are all my final answers here. I'm going to go ahead and erase my scratch work. And now we're about to really mix it up. So what I am mixing together is what we learned yesterday with what we've learned today. Because exponent rules do not only work independently of one another, they work all together. Kind of like a two-step equation versus a multi-step equation, okay? So we really do need to figure out how to work with all these rules simultaneously, all right? So let's be sure that these notes are written down, and we are going to start out our steps very similar to equations, actually. If you ever see a parenthesis with an exponent above it, that's kind of like distributing. You're distributing your exponent to all the exponents inside of it. We're going to always do that distributive property step first. So let's do that here in number 10. So I'm going to distribute the 3 to both of the exponents. And what I now have is, I have, whoops, that was a y. I have my two bases, x and y. Let's try that again. X and y. Okay. And so I am sharing. So 3 times 3 is 9, and 3 times 3 is 9. Now I'm going to bring down the rest of the problem that I didn't do anything with yet. So x times y squared. Okay. Now this is all being multiplied together. So when I am multiplying bases, I am adding the exponents, okay? So 9 and 1 gives me 10 x's. All right, and now I'm going to do the same thing with the y's. 9 and 2 gives me 11 y's. So here I needed to use my power rule that I learned today, And then I needed to use the multiplication rule, which we learned the second part of yesterday. All right, let's do example number 12. Let's do 12 together. So step 1, distribute everything. So let me just copy down my bases. I have a -2, an A, and a B times, and then I have another set of bases. So I have a 3, an A, and a B. So now I'm ready to get rid of these parentheses. So that 2 has a 1 above it. So that's 1 times 2 is 2. A has a 1 above it. 1 times 2 is 2. B has a 2 above it. 2 times 2 is 4. Let's move to the second parenthesis. That has a 1 and that has a 1. So 2 times 1 is 2. 2 times 2 is 4. 2 times 1 is 2. So these are all of my new exponents. Okay, what I'm going to do now is I am going to go ahead and do the multiplication rule. Okay, so -2 times -2 is 4. 3 times 3 is 9. And then I still have the a squared b to the 4th. And I have the a to the 4th b squared. Okay, now what I need to do is multiply all this stuff straight across. So 4 times 9 is going to give me 36. Now that I'm multiplying bases, I'm going to be adding these exponents. So a squared and 4, so 2 and 4 is 6. And I'm out of different colors, so I need to reuse the blue, but b to the 4 and 2 is going to give me a 6. So my final answer is 36, a to the 6th power, b to the 6th power. All right, and then let me just at least get you started on 13, because I know that fraction is probably a little tricky for some people. So I'm going to start out with step 1, which is getting rid of any fractions that I see. So that'll be distributed 3 times 6 cubed a to the 6th power, and I forgot what that b was, b to the 1st power. So 1 times 3 is 3. Okay, now I'm going to do that again. Distribute to there, so I have 1 squared over 3 squared, a squared, b squared, c squared. Okay, now let me just figure out how to simplify these numbers. Okay, so 6 cubed is going to give me 216, and then 1 squared is 1 over 3 squared is 9. Okay, now I'm going to bring down all my variables. So a to the 6th, b to the 3rd, a squared, b squared, c squared. And now I'm ready to do the red step, which is to multiply the bases. So 216 times 1 over 9, this times this is 24. Okay. Now I'm going to do my variable terms. So the a's, I have 6 and 2 is 8. The b's, I have 3 and 2, which is 5. And then the c squared, I don't have any other c's to put that with, so I just keep it c squared. And that's my final answer. So I want you to work with a partner. I know that I left you number 11 because it's a little simpler. 14 and 15 are a little bit more complex. They're probably 15 is even bigger than what you'll normally see on a homework assignment or a quiz. But if you can do number 15 and number 14, then you are doing really, really well. So I do want you to get that practice in, okay? So let's start by pausing the video and try number 11. And then when you come back, then we will look at number 11 before you move on so that you can build some confidence. So let's pause the video now. All right, welcome back. I have shown my work for number 11, and it was mainly just a practice of, again, steps 1 and 2 over here, okay? Multiplying everything by the power, and then combining and putting all my bases together using multiplication. So steps 1 and 2. Now I'd like for you to try number 14, and 14 will include combining like terms in your last step. So let's give that a try and see how you do, and then come back and I'll help you with it as well. All right, so here is number 14. I started out with step 1, distributing right here, and I did that in blue. Now, what I did from 2 cubed to the next line here, from here to here, all I did was figure out that 2 times 2 times 2 is 8. And then I just brought down everything else, okay? In my next step, in the term back here on the right-hand side, I had to combine any of those. So multiply a to the 4th times a squared, and I got a to the 6th power. And so I brought that down. And then I had to also do step 3, which is combining like terms, because I have 8 a to the 6th power plus 3 a to the 6th power. So 8 plus 3 gave me the 11, and then I kept the the a to the 6th power. I did nothing with the exponent when I did that last step. All right, so as far as the exponents are concerned, in blue we multiply first. Then in red we add, and then in green we do nothing. All right, so go ahead now and try number 15 on your own. Okay, so you should have already tried 15. What I'm going to do is just work through it with you, and then we're going to go move over to the other side of our page. So I'm going to bring down my bases, and then I'm going to bring down that minus and these other bases as well. Okay, and now what we're going to do is step 1, which is to distribute that exponent. So 4 times 1, 4 times 3, 4 times 1. Now I'm ready to go over to where I see the other parenthesis, and I'm going to distribute that exponent. So 1 times 2, 5 times 2, and 1 times 2. Okay, now what I'm going to do is bring down what was in the back here, x squared, y squared. Okay, and now I'm going to go ahead and move on to my red step, which is multiplying bases. So when I'm doing that, I am only working with the term that's being multiplied together. I'm not dealing with anything on the other side of the minus sign. So let's go ahead and put together. I see 10 x's and 2 x's, so that gives me 12 of them. And then y 2 of them and y 2 of them gives me 4. Okay, and then let's bring down and simplify that. 7 squared is going to be a 49. Okay, and now I'm ready to bring down the other side of this minus sign. Okay, so 3 to the 4th power will give me 81, and then x to the 12th, y to the 4th. Now I am going to erase this little note down here that we should have copied a little earlier. Okay, so now I'm ready to do my combining like terms step. first thing I notice is that x to the 12th, y to the 4th, they both have that, so they are like terms. So what I need to just do now is 81 minus 49. 81 minus 49 gives me 32. And then I just copy and keep x to the 12th, y to the 4th. And I'm finished. That is my final answer. Okay? Great job. We are about to come over and do some geometric application problems. Okay? Now on your paper, hopefully these black boxes that you see, hopefully they printed better on your paper than they did for my digital copy. But we just have 5 more to do, okay? We are going to do some review and some that's new. So I have already in the past given you a perimeter problem with a triangle or a rectangle, and I have asked for you to please find me the perimeter, add up all the sides, right? And I might have even given you a problem with area, but if I gave you an area problem, one of the sides would have just been a number. They would not have both had exponents or variables on them, okay? So that's the kind of area problem I used to give you. Now you're going to start seeing some like this today. So we are going to find both the perimeter and the area of each of these figures in 16 through 18, okay? So in number 16, remember the easiest thing that we can do is rewrite 5x squared and 12x. And then we can go all the way around this and add up the things that are the same. So 12x and 12x gives me 24x. And then 5x squared and 5x squared, that's a 10x squared. So that's my work for perimeter. That's completely all that I do. It's exactly a review of what we've done before. Okay, now let's go find the perimeter of this triangle down here. So things that are like terms, I see 4a squared b and 10a squared b. So that gives me 14a squared b's. And then this 3ab, there's nothing to combine with it, so I just bring it over. 3ab. And I'm finished. Let's get the perimeter of number 18. Now I did add here for you that this is an equilateral triangle. Okay, so what that means is that all 3 of these sides are going to be exactly the same. 20 m cubed n to the 5th, and then 20 m cubed n to the 5th. So you kind of had to know that this was an equilateral based on the fact that this line in the middle is cutting it directly in half, okay? So now I'm ready to combine all my like terms. Well, they're all exactly the same like terms. So I've got 20, 40, 60, and then m cubed n to the 5th. So that's my perimeter. So completely and utterly review with perimeter. Now let's go back up to 16 and start practicing our area. So I do have the formulas for area out to the left-hand side of my paper. I do recommend that you write all of these formulas down. You will see problems like this on your quiz, and it's going to be super beneficial for you to have your notes completed the way that they should be when you take your quiz, okay? So in order to find the area of this rectangle, I am going to need to multiply the 12x times the 5x squared, because my area of a rectangle is length times width, okay? So we're going to need to multiply these. So what that means is I am going to do 12 times 5 and get 60. And then I see my x, they both have a base of an x. That's a 1 and a 2, which gives me 3 x's. Okay, so I have found my area right here of my rectangle. Now let's try to find the area of the triangle. It's going to be 1/2 base times height. Okay, so my base is 3ab and my height is 10a squared b. Okay, so what we can do is start out by multiplying these numbers in front. So you can multiply them in any order that you want to. So, or you could do them all at the same time. So 1/2 times 3/1 times 10/1 gives me 30 on top and 2 on bottom, which equals 15. Okay, so that's sort of my scratch work for multiplying my three numbers. So I did that, that, and that. Now I'm ready to move on to my variables. Okay, I have an A and I have a B, so let's go ahead and see what they're going to equal. 1A and 2 A's gives me 3 A's. 1B and 1B gives me 2 B's. And that is my final answer for the area. Okay. Now, let's see, how am I going to find the area of this equilateral triangle? Well, the area formula for a triangle is still the same. It's 1/2 base times height, okay? Well, for this problem, my base is 20 m cubed n to the 5th power. And my height is where this arrow was pointing to that line. That's the height of the triangle. So it's this number, 4m n to the 5th. Okay? So now I'm ready to multiply all this together. I have 4 times 20 times 1/2. 4 times 20 times 1/2, if you can see how that works, okay? So 4 times 20 is 80 over 2 gives me 40. Officially, I have a 40 in the front. Now let's do my m's and n's, and I will be done with these first 3 example problems. So for my m's, I have 3, and 1 more is 4. For my n's, I have 5 and 5, which is 10. And that is my final answer for my area. Okay? Alrighty. We've only got 2 more problems to go. Okay, so we are now going to find the area of a trapezoid and the area of a circle. Now I wrote the formulas out to the left for you so that you have those to use. Okay, so I'm going to bring my formula over. 1/2 base 1 plus base 2 and then times the height. So here's your bases, base 1 and base 2. Okay, so I'm going to write those in my formula. 4x squared y plus 7x squared y. And then my height right here, that's the height, is 2xy. So I am ready to start doing my distributive property, combining like terms, all that stuff I got to do. Okay. The first thing I want to do though is inside this parenthesis where you see red, I want to combine the like terms I see. So I have a 4 and a 7, which gives me 11. X squared y stays the same. And I'm going to bring all this stuff down now. Okay, so now I have just what I had up above. I have all multiplying together. Okay, so this time I just had to do the adding my like terms together first. And then I could do my multiplication next. So I'm going to do 1/2 times 11 times 2. And that's going to give me 22 divided by 2 is 11. Okay, so that's 11. I've dealt with all three of my numbers. Now let's deal with these exponents. So my bases are x and y, and this will be my final answer when I'm done because I see I only have one term left. So the x has a 2 and a 1, which is 3. My y's are 1 and 1, which is 2. And I'm finished. Okay, let's look at example 20, and that is the area of our circle. So we have pi r squared. So we're going to add in the power rule that we learned today. Okay. So my r, my radius, is that number right there. Okay. Radius, remember, is half the distance of a circle. So from the center to the outside edge. And in this case, my radius is 3xy cubed. Okay. So what I need to do before I can move on with this is I need to get rid of the parentheses here. So remember, our exponents there are snobby, so we do not want the 2 talking with this base of 3. We only want it talking with the exponents. So here's my 3 bases. They're going to stay the same. And then we're going to bring down this times pi. So I now have 1 times 2 is 2, 1 times 2 is 2, and then 2 times 3 is 6. So these are the exponents that I have. And I'm just about finished. All I'm going to tell you that you need to do now is simplify this 3 squared is 9. Okay, and then I'm going to put the pi behind it. 9 pi x squared y to the 6th power. And I'm all finished. That is my solution. You could, if you wanted to, go in your calculator and say 9 times pi is 28.27 if you wanted to round it. But if I just leave it as 9 pi, my answer is going to be so much more accurate. Okay? Alrighty. So we've done lesson number 2. We did a lot of review and then we added on some new stuff to it today. So it is important that we practice. So be sure to go into Google Classroom and complete the practice assignment that is posted. Until next time.